Milestone3 is accumulator-based vending machine. The objective of Milestone3 is interfacing CPLD with simple input-output device, design of high-level modules based on specification, and building a circuit on a strip board. The components needed to build a vending machine is adder, accumulator, night rider lights, Prescaler, Comparator, binary to BCD converter, input filter, and selector. So let's look at the first one is adder. The ripple carry adder that we have learned from the milestone one, and we just use the knowledge that we have learned from the milestone one, build this circuit, and this is the circuit, and this is the comparison report is successful. Okay, so let's look at the second one is accumulator. The function of the accumulator is to store the data from the input when the clear is 0. When the clear is 1, the output will become 0. So this is the comparison report and it's successful also. So let's look at the output, the waveform. So as I mentioned before, when the clear is 0, the output will follow the input 1, 2, 3, 4, 5. And when the clear is 1, the output will become 0. When the clear is returned to the 0, the output will follow the input. So that's all for me. Thank you.
Okay. So after finish creating the adder and the accumulator, the next thing that we have to create is a night rider lights. If you remember in Milestone 2, this is what we created. But unlike in the Milestone 2, we have a few modifications, such as we need to add a control signal to enable and disable the light so that the LED runs only when the input is high. And the second modification is that we have to add a status signal that indicates when the lights have run a complete round. This is the circuit, and I will show you now is the compilation report, and this is the waveform result report that we come up with. Okay, that's one thing. The next thing that we have to create is a prescaler. Prescaler is basically an LP counter with two outputs coming out of it. We have clock 1 and clock 2. And for this prescaler, we do not have to compile it, now we have to simulate it. But we will add it at the final construction stage later on. So we'll skip that and we will go right next to the comparator. Okay, this circuit might look very complicated, but basically it only has 2 input and 1 output at the end of it. This is the compilation report that we have, and for the simulation output waveform, this is the result. With the output G turns high when A is greater than B, as you can see here, right here and here. And that's it. Thank you very much.
For binary to BCD converter, we will refer to the lecture note, page 14, and we found this table. Based on this table, we built 4 K-map to find the Boolean equation of the 4 output. And then based on this K-map, we built this schematic diagram for 4 of the output. And then we created a symbol file for this. And then based on the project guide, we built this schematic diagram. This is binary to BCD converter. And then we've also created a symbol file for this. After that, we connected the binary to BCD symbol to a BCD to 7 segment decoder. This will be the final schematic diagram for this section. And then next one will be the input filter. We built this schematic diagram based on the project guide. This input filter is basically to filter the input signal to produce a smooth output. And then we have also created a symbol file for this to be used later. And then next part will be the selector. This will be the selector. We use 3 bus marks to build this selector. The bus marks here is for input 2, and then the bus marks here will be the input 5, and then the bus marks at the right will be is used to select either input 2 or input 5. And we have also created a symbol to be used later. And that's all from me. Thank you.
So now that we have finished building all the modules, we put them all in a file, and this is the whole design without the Prescaler. We have the filters acting as a debouncer, the selector that feeds the ripple carry adder from milestone 1, and the adder adds up the input data coming from the user and the accumulators data. Then they are the result is compared with the comparator and is displayed using the binary to BCD converter for the 7-segment display. The comparator outputs for the Night Rider, and here is the compilation report, and here is the waveform. So here we have the user input going 255. These are added up here as displayed here. This is the 0, 2, this is the 2.57, and this is 12. And when the adder reaches more than the accumulator reaches more than 11, the Night Rider is activated, going a full round, and after that the done LED is activated. And when the done LED is activated, it resets clears the accumulator as shown here. So it goes back the same way here as 0. And this is another test going 25222, which is equal to 13. So now that we have simulated this, we can now add the version with the Prescaler, and after we compile it, finished compilation, we go to the assignments, go to the pin planner, and start assigning all the input and output to our preferred pins. We have the clock can be set as 64, 12, any clock pin as shown from the legend here. And after finishing that, we recompile, and after recompiling we go to the programmer, and after connecting the CPLD, we add the file, and then we run it. And when the progress is finished, we can go straight up to the simulation, the demo. So that's all for me. Thank you. This is the demo for Milestone 3 accumulator-based vending machine of group 13. Here are the buttons that we can click to add more cents to the machine. So if I click here, it goes up to 2. If I click again, 4, 6, 8, and this is for adding 5 or 50 cents. So because now it's more than 11, the Night Rider starts going from A to F and backward, and this is the done LED. When done LED is on, the counter resets.